Mushrooms! I love them. Stuffed mushrooms, sautéed mushrooms, baked mushrooms, mushroom pot pie, mushroom soup, mushroom stew, mushroom styrofoam packing material. I don't really understand that last one, which is why I'm here in Green Island, New York, to find out.
At first glance, you could be in a restaurant kitchen. Storage containers full of rice and grains, cereal by the mounds. But if you look a little closer, that pile of succulent cereal starts to look more like honey bunches of buckwheat hulls and cotton gin trash. If this is a kitchen, I'm eating in tonight. Luckily, it's not. It's a lab. And what you see here ends up here. Nope, this is not a delicious Rice Krispie treat. It's the next generation of packaging. Lightweight, sturdy, and you don't even manufacture it, you grow it. It's called EcoCradle, developed by Ecovative Designs as a green, energy-efficient alternative to styrofoam. But the way the two materials are created, and the way they're destroyed, could not be more different. That white stuff there is mushroom roots, or mycelium, those natural, sprawling, sticky, veiny threads of fungus.
I used to see this mycelium in the woods growing up as a kid and thought it was a cool glue. We essentially use mycelium as a glue in our process to bind particles together, just like you'd use a plastic as a resin to hold foams together.
That's Eben Bayer, who invented the mushroom packaging and founded the company with his college buddy, Gavin McIntyre.
So what do you got against styrofoam?
Well, there's a couple big issues with expanded polystyrene or styrofoam. The first being the energy content in this material. It's made from a precious resource, fossil fuels.
Styrofoam is a brand name for expanded polystyrene, and Eben says that making an EcoCradle takes just 1/10 the energy of making the same amount of styrofoam.
The other big problem with this material is it's got all this energy in it, but it doesn't break down at all in the natural environment.
Think about it. The moment the styrofoam is ripped off your son's new Xbox or your uncle's new wall-mountable singing bass, it goes straight to the trash to clog up a landfill. Hardly any recycling programs will take it. But EcoCradle disintegrates harmlessly. To understand how and why, I got to see it being made with Ecovative Environmental Director and Design Engineer Sam Harrington.
This is the raw material for EcoCradle. So this is cotton gin byproducts. It's all the burrs and the sticks and twigs, everything except for the fiber that makes your shirt. This bin agitates it and sucks it up into our production system, and from there it's pasteurized. That kills any mold spores or bacteria or bugs that might come off the farm.
Right, so there could be bugs and dangerous spores in this that I'm holding here.
Yeah, who knows what comes off the farms.
Sure, it's dirty, but that's kind of part of the beauty. This process can use all kinds of agricultural waste, depending on what's native to the region. One place might use sawdust, another rice husks. Keeping the energy output to a minimum is the goal, so Ecovative makes sure they get the waste material from local farms. And unlike fossil fuels, this garbage will always be cheap. Peak oil, perhaps, but you don't hear about peak seed husk.
This is EcoCradle after it's grown for about a week. So we take that plant matter that we showed you before and add mycelium.
Yeah, you can even actually see the husks that I was just holding in my hand that are still in there. This is only after 1 week.
Yep. So all those little fibers are reaching out towards the husks because they see it as food, and at the same time they're bonding it all together in this network of fibers.
This is where the fungus performs its magic. It's a process that takes place every day, everywhere from the rainforest floor to that old Chinese takeout in the back of my fridge. Mycologist Sue Van Hook takes me into the woods to explain.
So the fungi are this entire kingdom of organisms that are underneath our feet. The fungi are debris chasers. They're nature's recyclers. If we didn't have the fungi, this woods would be up to the sky in leaves and twigs and carcasses.
So that job of a fungi in the woods to be the demolisher of debris, is that essentially what you're trying to harness at Ecovative?
That's exactly what we're doing. We go out into the woods, we find a mushroom or a fruiting body and take a little piece of tissue.
That little bit of tissue is taken to a lab where technicians clone it repeatedly. It's an impressive example of sustainable production. There's no strain on the fungi, and Ecovative has an endless supply of an already renewable resource. A few cells from this tiny little specimen are all that's needed to make thousands of EcoCradle parts.
Can you see all the little microscopic fibers?
Yeah, all the little hairs, it's the little fibers.
On a microscopic level, it's a busy scene. The interconnecting branches of mycelia are so numerous and so haphazardly sprawling, they could have been designed by the Los Angeles Department of Freeways.
Looks like mold to me.
Yep, it is.
Eventually, the block of mycelium is baked at a low temperature to dry it out, lock in its shape, and kill the shroom. This is the most energy-intensive part of the process, but it's still a whole lot better than Styrofoam's superheated steam.
And so I guess this is the final product, right?
Yep.
I know that you guys are working on applications to do with home insulation. You can definitely see that here.
Right, it's great insulation and it's fireproof.
It's fireproof.
Yep,
Can you prove that?
I sure can.
You might think something made entirely of organic material would burn like organic material. But no! Although please don't try this at home, I'm a professional reporter. So I may not know what I'm doing, but I am insured.
And now, regular styrofoam. Ooh.
Ditching artificial packaging for all natural packaging could reduce our fossil fuel consumption, our trash, energy costs, and carbon emissions. Ecovative has big plans.
This technology is in its infancy, so it's sort of like where plastics was in the 50s. We expect to continue to extend the technology, eventually even making things like thin films, like a cellophane.
If these guys have their way, in the future, all packaging will be energy efficient, biodegradable, and edible. Though it could probably use a little salt. In Green Island, New York, Josh Zepps, Energy Now.